We've learned how to factor using the distributor property, but what do you do when that's not an option? So if we look at this first polynomial, it's got four terms. We've got 2xy plus 7x minus 2y minus 7. And so the first thing we would do here, in fact, the first thing you should do when you're factoring anything is to look for a greatest common factor. And if you start looking for a greatest common factor here, you'll see that this polynomial doesn't have one. There is no greatest common factor. And so factoring using the distributor property, meaning you just have one term outside a set of parentheses, is not an option. So instead we do something called factoring by grouping. And factoring by grouping comes up a lot when you have four terms, but not only then, we can also use it when we have three terms, which I'll show you how to do a little later. But factoring by grouping works like this. What we do is we group just the first two terms together. So our first two terms here are 2xy plus 7x. And 2xy plus 7x, they do have a common factor. The common factor of 2xy plus 7x is x. They both have an x in them. So the x would go outside the parentheses, and then inside the parentheses, I would have two terms separated by a plus sign. So what would go in parentheses? Well, if I have a 2xy first, and I factor out an x, what's left? That would be 2y. X multiplied by 2y is 2xy. And then the second term was a 7x, but I factored out the x, leaving me with just a 7. X times 7 is 7x. So I have factored the first two terms. Then I group the second two terms. Negative 2y minus 7. And the negative here is important. Negative 2y minus 7. If you have terms that start with a negative, like these two do, you need to factor out the negative. So when I look at negative 2y and negative 7, it looks like they don't have anything in common, and they don't really, so we'd factor out a 1, just a 1 from these. But because it starts with a negative, we factor out a negative 1. And so in between these two, what would we have? A minus sign. So we've got negative 1 times what is 2y? Well, that would be 2y. Negative 1 times 2y gets us our negative 2y. And then negative 1 times what gives us 7? Well, a negative 1 times a negative 7 would give us 7. And I don't love that we've got a minus negative there, so why don't we just go ahead and rewrite that as a plus. So we'll do a plus 7. Negative 1 times 7 gives us a minus 7. Okay, so now we've factored the first two terms and the last two terms. Still looks pretty ugly, but believe it or not, we're one step away from the answer here, because these two terms have something in common. If you look at just this and just this, they have something in common, which is that they both have a 2y plus 7. Both of them have a set of parentheses that is 2y plus 7. And 2y plus 7 is going to be my greatest common factor. I'm going to put a 2y plus 7 right here at the beginning. Let me write this better. Let's include the minus sign here. So if I take a 2y plus 7 out of both of these, what's left? Well, I've got an x and a minus 1. That's what's left over after I remove a 2y plus 7 from both of these. So I'm left with an x minus 1, and that's our answer. That's factoring by grouping. So this is one of the ways that we can take a polynomial and factor it into two parentheses. We've multiplied two parentheses together to get a polynomial. Now we're doing the opposite. We're taking a polynomial and factoring it back into the two parentheses. And we can check our answer by doing the distributor property. So we do 2y times x, that's 2xy. 2y times minus 1 is minus 2y. 7 times x is 7x. And 7 times minus 1 is minus 7. And that looks exactly like the original problem. So we can check by doing multiplication to make sure that we did it right. Okay, let's look at this second set here. Again, the first thing we look for is a greatest common factor. We always want to do that first, see if there's a greatest common factor. And in this case, there's not. These four terms do not have a greatest common factor. So we factor by grouping. We group our first two terms together, 4xy plus 3y. So what is the greatest common factor of 4xy and 3y? Well, the only thing they have in common is y. So y outside the parentheses, and inside we'll have two terms separated by a plus sign. So if we have 4xy and we remove the y, what are we left with? 4x. And then if we have 3y, but we factored out the y, we're left with just 3. Okay, so there's our first grouping. Let's do the second one. Minus 20x minus 15. Let's factor those two. Minus 20x minus 15. They don't have a variable in common, but they do have a number in common. 20 and 15 can both be divided by 5. So they have a common factor of 5. And because this starts with a negative, we're going to factor out a negative 5. Negative 20x divided by negative 5 is a positive 4x, and negative 15 divided by negative 5 is a positive 3. And now you can see when we look at these two terms that we've come up with, they've got a set of parentheses in common. Look at that. They both have 4x plus 3. So that's going to be our first set of parentheses. And then if we remove the 4x plus 3 from each, what is left over? A y minus 5. And that will be our second set, y minus 5. And there's our solution. And we can check this as well by distributive property. 4x times y is 4xy. 4x times minus 5 is minus 20x. 3 times y is 3y. And 3 times negative 5 is negative 15. And that is identical to the original problem, verifying that we have done it correctly. So this is factoring by grouping. It's one of the ways that we can take a polynomial and get it into two sets of parentheses. As you can see, there are quite a few steps. This one takes some practice. It's going to take a little bit of practice to get this right, but it is a really accurate way to factor. Doesn't require a lot of guessing, like trying to figure out what the two parentheses should be, which I'm sorry to say, back in the olden days when I learned how to factor, we learned the guess and check method, which I will show you a little bit later is the worst way to factor. But that's how us old timers did it. So this has a few steps, but there are a few steps that will lead you to the correct answer every time, as opposed to guessing and multiplying. You kids are always saying, how come you show us the hard way first and then you show us the easy way? Well, this is the easy way, believe it or not. I'm showing you the easy way first instead of showing you the hard way. But rest assured, I will show you the hard way later so that if you really want to exercise your brain, you will have the opportunity to do it the way we pilgrims did in the olden days.